All right, so let's try this and see if we can make it work today. So the zybook, we're working in chapter 2. I think we were about here. All right, let's try this and see if we can make it work. So the zybook, we're working in chapter 2. I think we were about here. All right. Now, maybe I'll over-echo myself. Bear with me. We're gonna, technology, it loves me. Come on. All right, so do you guys remember us talking about, I remember us talking about the combo things. This one in particular, kind of, I think, does too much extra information. So one with the physics formula, the gravity and the constants. So what I'm learning and I'm finding when I go through this is it does read like a word problem. And it's kind of scary because it sounds like it wants you to figure out a physics equation. But what you need to learn as computer programmers is what is vital to the program and what is just fluff, right? Because we're not physicists. We don't want to sit down and hand calculate all this stuff because we're programmers. We're going to let the computer do it for us. So in this one, it's like compute the approximate acceleration of gravity object. This could really simply been shortened to compute this equation using this information, right? So we want to take the equation right here and convert it to Python code and fill in using the variables we created in Python, right? Does that make sense? I don't really care what the constants, are for. I care that you set the equation up and it gave you the answer you were expecting. So I would probably start off by coming down here. And it's already set up the variable G. It's already set up the variable M. It's set up accelerate gravity and gave it a value of 0. So this probably is what we're solving for because they gave it a 0 value. Gave it an initial value. This is very much something more experienced programmers will do. They'll go ahead and set up a variable, and if they don't know what's going to go in it yet, they'll give it an initial value. So if it's a number, a lot of times they'll put 0 in it. Sometimes they'll put -1 in it. Just something to hold space and have it ready. You can actually in Python create the variable as you're going and not have to do it in the beginning, but this is just how some of us were taught to do it organizationally wise. So we're going to ask the user to input the distance to the center, right? So we're going to look up here. So we need to make accelerate, or their abbreviation for gravity here. And we want to set it equal to that formula. So we're going to go G, because they use G as a variable, times M. Remember our parentheses, we need them for order of operations. Excuse me. Then we want to divide, by D. In this case, they didn't use D as a variable name. They used distance to center or distance underscore center because we asked the user for that. So I'm going to put that word in where the D is, and we're going to go. And remember, if we want to raise something to a power, we use 2 stars. Right? Does that make sense? Now, the formula has that in parentheses also. you absolutely can add that here or not. It should work both ways. Does that make sense? So up here, it put it in parentheses. And if it makes it read clearer to you, you can do it down here. But, and if I run this, but this makes it sound like they're asking you to do a whole lot more than one line of code, right? If you read all this, this makes me think that they're asking a much more complex question than plug in to this formula. But this basically boils down to, they want you to plug your variables into this given formula in the syntax that Python's going to read. Now, did I need to know the gravitational constant and the mass in the question? No, because they gave it to me in the variables.
Could have just omitted that part entirely.
Right. Yeah.
It is G.
Yeah.
Not what G is, but G.
They could have summarized that down to G is equal to this number, M is equal to this number, which they did in the code. Right. And that would have clarified what they were asking, I think, in my opinion. So you're all gonna go, well, why didn't they write it that way? Because I guarantee you, when you get your degrees or you go out and get a real job programming for a living, you're going to have a client that's going to bring in this huge Word document or some other document and say, I need a program to do this. And you're going to have to go through all that information and pick out just the important pieces. And you have to figure out what you can ignore. And then you're still going to have to go back and ask them more questions because they're not programmers, so they probably have not given you all of the important pieces. So we're going to learn to decipher stuff. And if I can help you with that, let me know. I used to teach this in high school at Java, and I would hand them things and we would circle nouns and we would circle verbs and we would circle things like that in the assignment, because nouns were usually going to be your objects and verbs were usually going to be your functions. They're going to be the things that the objects are doing. So that's how you tie English into computer programming. But so does this help? Does this help?
It does on that one. I just
Okay.
You know,
We could do more.
it makes way more sense after you explain it than I can say it. Yeah, it makes sense. And I get to a different one. I'm like, okay, well, you know.
So practice. I'm gonna pay attention. This is all gonna boil down to practice. And beating yourself up about it is a waste of time.
They started giving you like a show answer option. I think the last two things here.
So they-
Like, and it doesn't list it as being complete. It just shows you the answer.
Right.
Gives you option to do it again. But giving me like a example of what it's supposed to look like, the format, and then trying to do that. That's brilliant. You know?
Yeah. What I can see and what you can see are a little bit different. But on these challenges and stuff, if they have those options, like I know you can view your last submission. So if you forget what you tried before because you had to go away and do something else and come back, go look at it. And sometimes after you've gone away and done something and you came back, when you look at what you've done, go, oh, I see what I did wrong. But you've been looking, the first time you've been looking at it for so long, you just couldn't forget. I have a solutions button. And I don't think y'all have a solution button on everything, but I do because I have the teacher version. But yeah, absolutely don't feel bad if you need to go look at their sample solution and figure it out. When you need to be concerned is after you looked at the sample solution, you still don't get it. That's when you need to send off an email or Google Chat or something to me or CSX and say, please explain this. And you won't hurt my feelings if you ask me to explain something, or if you tell me that I didn't do a good job explaining it, because we all learn differently. And I will tell you, as we move forward and start doing bigger labs, to go ahead and ask your neighbor to look at your code too, because they're going to catch something you don't see. They also might explain it in a different way than I did that makes more sense to you. Because, you know, I'm a middle-aged woman. The way I think about things will be completely different than a traditional college student. All right, so we're talking about modulo operator. Remember, it's the one that is just going to give us the remainder of the division. So divide the two numbers, and then the output or the answer will be the remainder. It does come in handy. It helps you know if you can divide things into equal groupings. It lets you know I've seen it used to tell if it's an odd or an even number. You know, it comes in handy from time to time. You'd be amazed how much it comes in handy, because it's just a simple way of doing things. So this next one here, they want us to we want to do minutes to hours, right? So we have a whole bunch of minutes and we use the modulo and divide it by 60. We know how many, we know we have uneven number of hours, right? So we can find out how many minutes are left. So first you divide it by 60, and you find out how many hours you have. And then you do the modulo of, and you find out how many minutes you have. So if you wanted to just know how many minutes you would have after you take the wholes out, you use modulo. So in this case, the user is going to input the number of minutes. When it has something in here, that means that's what's going to print to the screen. You've been just doing straight input things that don't really make a lot of sense. But so minutes is going to be a value that's going to come from the screen. We want it to be an integer, so we're going to go ahead and force it into that type by putting int and then putting the command in parentheses. We're going to do the whole number division with the 2 slashes to find out how many hours we have. And we're going to do the modulo to find out how many minutes we have left over. Right? So if I put in 135, that should tell me that I have 2 hours and 15 minutes left, because 60 goes into 135 2 times evenly, and then I have 15 minutes left over. Did I need to write a program to figure that out? No, that's probably something we could have done in our head, but it's an example. So the challenge portion is what I actually you get a grade on, right? So let's do that one real quick. So we want to type the program's output. So what would be the output of 11 divided by 2? Anyone?
5.5.
5.5. Oops, not enter.
Enter actually.
Oh, they did want the enter. Never mind. Sorry. I should have known that. All right, my son actually complained about that. I assure you, you can make no complaint about the book that I haven't heard already, because my son is taking this with another professor using the same book. And every time the book does something weird that he doesn't like, he comes and finds me. He lives in my basement. So he comes and finds me. Yes. Yes. Absolutely. That enough? So this one, I have x is equal to 17. 17 doing the whole number division, because we have the 2 slashes. So we're gonna decide 17 by 3, and we only want the whole number. So 17 divided by 3 gives us 5. No, yeah, 5.
Hold on.
5 is the whole number. Does not round. Computer science will never, ever, ever round for you. Always is going to go to the lower value. Modulo 17 modulo 2. The answer is going to be,
Well, no.
we're doing modulo this time. 17 divided by 2. What's the remainder? We're divided by 2. Sorry, I'm sorry, I messed that up. We're divided by 2. What is the remainder? 1. Because it's an odd number, right? So I still can't believe you have to put the inners. I believe it. All right. So does that show you the different ways you can divide a number? You can get a decimal number by using the single slash. You can get the whole number and throw away the fractional portion using the double slashes. You can keep just the fractional portion as a remainder by using modulo. I'm not doing all these challenge activities for you because kind of the point is for you to do them. Is there one that you are particularly stuck on? Probably. Is it helpful for me to do this in class? They don't talk to me. You're the only one that talks to me. So, okay. Feel free to use your voices in my class. I really want you to interact. Last semester was extremely quiet, but it was 8 a.m. classes for me, so we don't have that excuse this time. But look through and see if there's any particular challenges. Even if we need to go back, I can go back into some of the other sections. But if there's something you didn't understand,
I know I have one that was back.
okay, we'll find it, and before we leave today, we will do it. All right, so this one was all about modulos. You can use it just to shift things, pick out pieces. We are going to be working with modules, and it is going to come up again later. We have a whole chapter on modules. We're not going to do a lot in depth with like creating our own or anything like that, but I want you to know how to import them and use them. So like there's a math module. It has square roots, all sorts of math functions. I can't think of any right off the top of my head, but exponents, floats, yeah, min, max, all that stuff. It's already created. So we want you to be able to just use what people have already created and packaged up for you and put it in the standard library. So what we're going to do as far as modules in this class is they're kind of like little scripts that run and they do something and you don't have to reinvent the wheel and, you know, have to type out all the code to make that happen. What we want you to be able to do is just be able to reference those functions. So a lot of times you're going to use math a lot. You're going to use string. You're going to use pre-built components. We're going to get into turtles at some point. We're just going to put a cute little turtle on your screen and let you draw with it. But these are modules that are already built. So in this particular one, it is going to use a module . So the module would have different pieces. We're going to use the keyword import every time we want to use a module that's already pre-built. We're going to import it. Import statements should always, in my opinion, and since I'm grading your code, my opinion is when it counts, should be the very first things at the top of your file. Can you put an import statement further down in your code and it run? Yes. As long as you do it before you actually try to use whatever you're importing. But if you do it that way, you often will forget to put it in. So if you put the import statements all at the top, and myself or somebody else who goes and looks at your code, or you go back and look at your code a year from now, you will very clearly at the top have a list of all of the modules that you've used that you didn't create or that you did create and you import it. This, to me, is a logical place to put them, and it keeps you organized. I'm big on organization. I like code to be clean. And you're going to find that all of the professors in this department have styles that they're going to grade you on. Needs to be clean, clear code. The dot notation means that we're going to, every time after I imported math, I could do math dot square root. The dot means that I want the left-hand side of the dot is the module I want it to come out of. The left-hand side or the right-hand side would then be what function or what information I want from it. That makes sense? We use dot notation in web pages. So you have different pieces of a web address, and it's done in dotted notation because those sections are divided up by dots. Same similar concept. So we also in scripting languages use if it's specifically scripting, and you'll see this in the book a lot. We won't use it in idle because they're running Python as a script. We're going to be building it and running as an application. But it can run both ways. So the web-based one is going to run them as scripts, but you're only going to see that like when you get further along, it'll be down at the bottom, and it'll be a section that says don't change this code because this is what makes it run. So, but we're going to use a main function and build it out and run it differently. Just be aware they're there. It's one of those be aware of situations, and it, and know the terminology, but we're not gonna type it a lot. All right, I'm afraid to ask what went wrong over there.
Yes, you are.
Okay. All right.
It's the one I was trying to go back to later, and I just changed one more thing. So.
Told you if you go back to it later, it works. Okay. I know what I'm talking about every now and then. All right. So like I said, we're going to do a lot with the math module. So be aware that math module is going to be there. So in this particular case, math dot square root means that we're going to the math module. We're using the square root function, and we're running it on number. Right? Function is the actions you want to take place. A function call is when you do something like math dot, the name of it, and give it a parameter. That means you activated it and you want it to run. So you can define a function, and then when you're ready to use it, you call it. All your functions should have unique names. They should all be clear names if you're writing them. If they come from the standard library, you have to go, what the heck? How about they're there? Like SQRT kind of violates all those things that I told you about naming things and spelling it out because it's easier if it's clearer. Obviously, when they built this, the programmer abbreviated square root.
That's square root.
Yeah.
It's SQRT.
Sure, we're old. So
also squirt, So.
Yeah, some people could read it as squirt. Yeah, bless you. Arguments. Arguments are the things inside of the parentheses. They're the stuff that the function needs to run. So if I ran square root, inside the parentheses, I need to put the number I want the square root of. Not all functions have arguments, but all functions do have parentheses. So if you're calling a function, you should have an open parentheses and a closed parentheses. If it needs arguments, they're in between those. If it needs no arguments, there's nothing in there. They're just empty. That makes sense? So print can have 0 to many arguments, right? Because I could just do print. If I do print with nothing in it, it just gives me a blank line. It's just a return character. And for formatting purposes, you might want to do that sometimes. But if I'm doing math and I need the power, I can do POW, and everything inside the parentheses are arguments. If it takes more than one argument, it has a comma separating the two arguments. So the power thing basically says first argument raised to this power. So this would be the power the second argument would be the power you were raising it to. The first argument is what you want to do. So basically this has an equation and you want to raise it to however many years power. Or if you wanted to square the whole thing, you would raise it to the power of 2. So you could put a variable here or you could put a number there. You're like, okay. Here are some math functions that you might use. There's exponents of the powers, cosine, tangent, arc cosines, all those things are in there. More things than we will use in this class. We are not doing trigonometry in here, but be aware that if you ever have to write a program that does trigonometric functions, that in the math module, there's ways to handle that, and you can go look it up. What I will teach you how to do is how to look up the standard library functions and be able to find the stuff you need. But I am not going to require you to memorize.
Isn't that something that you would later on, if you had to use that you would just know what you're going to teach us to find the correct module and then pull that up on a second screen and use it as you need?
Absolutely. I've been programming for 30 years. I always have a second screen open. I know where to go looking for the stuff I want.
That's the important part.
That's the important part, you know, where to find what you need. Does this mean that you should go to a website where somebody created the program for you and copy and paste the entire program? No. This means that you should use the resources available to you from the standard library and from modules that are freely accessible to you. We don't need to go to Stack Overflow and copy and paste somebody else's answer. And Stack Overflow will call you out if you put your homework problems in there and expect them to answer you. People have tried that. But you know there's ways to cheat. You and I both know that there are a multitude of ways to cheat in any class now. The only people you're hurting by cheating is yourself. Because if you don't know the material from this class and you go to the next one, you're not going to know that either. And sooner or later, you're going to get called out for it. And I might look stupid, but I'm not. I just about every semester catch at least one person cheating.
Can I ask you how cheap here? I mean, without giving it away, what are you referencing? Actual copy paste?
Yeah, actual copy paste.
Yeah.
Yeah. We had an instant last.
A code, you mean, that you
Yeah.
passed on a project or something?
Yeah.
Okay.
Because everybody has a coding style. Look, prime example. I used to teach high school computer science, and we used a college level textbook in the class because there wasn't a good high school level textbook. one of the professors at a university that was also using the same textbooks I was, posted the answers to the homework for his students after they did. But he put it on a public website that was not password protected. How my students found this, or how much effort they put into finding this, I have no idea. But they found this site. And they are such kind-hearted souls that they downloaded it all to a thumb drive and passed it around the room. The way I program, the way you program, the way a college professor programs, and the way a textbook author programs are different levels of programming, right? So a college professor or a textbook author is going to use those really long variable names. And their comments are beautiful. They're very well thought out. They are very descriptive. High schoolers do not write on this level.
For the handwriting style to it.
Yeah. There's a,
It's not yours.
yeah.
Calligraphy.
Well, no, it's all text,
I'm
copy
saying
and paste.
like-
But yeah, it's like comparing two people's, handwriting. And to top it off, on top of that, they gave it to the one student class who thought it was intelligent to open it while I'm standing behind him. I'm talking to the student in the row in front of, and I turn around and he's got the answer key open on him. And after he did that, all I had to do was go back and see how many of them were 100% identical. Over half the class cheated.
What you do.
Gave them all zeros. Called their mamas. Because you can do that in high school. High school, you can call them mamas. The sad part is at least two of them were other teachers' children.
Got one speed though.
Works great. So there's ways to tell.
Just curious.
I've had
You have teach for technology.
we've had students go in and try to convince the CSX tutors to just tell them the answer or do it for them. And most of them, I would say all of them, are not going to jeopardize their own education to cheat for you. So don't harass them. If they say they can't help you, they can't help you. And it's usually because I've told them they can't help you. So if you want to yell at somebody, come yell at me. Won't do you good, but you can. Come yell at me. But you only hurt yourself if you're cheating. Because I'm willing to help you with anything. Come to class, ask questions. I'll help you. I'm sorry, I got way off track there. But so the math functions that you're going to use, do I know they're out there? Absolutely. Do I memorize them all? No. If I have a few memorized, like I know if I ever need pi, that I can call pi. I know if I ever need the exponent of something or the power, if I need to raise something to the power, I have that one memorized because I do it fairly frequently or frequently enough. I like min and max because it gives me the minimum and the maximum of a list, things like that.
The floor ceiling next.
Yeah, well, I mix languages, so sorry. But when we get into lists and things, there actually is a function in a list that'll find the minimum. This one?
That thing.
This scares you, huh? I
It scared me. I don't like it.
Okay.
Scared at all.
So what it's telling you is that you're going to need the power, the math power for that one, and the math power for that one, right? Because it's raised to a power. So if I use, scroll back up here, power, x, y, I put the equation part here, and I put the 2 where the y is. Does that make sense? Oh, come, we'll just do it. I don't know if that'll work. I'm gonna hoping it will. So we want to do distance equals math dot square root of math dot how.
Your very first one, the distance, is that point distance or? The distance on purpose.
It says distance equals square root of, so I just created a.
Yeah, if you scroll up, it says sign.
Oh, yeah, okay, so, yeah, because it's gonna not grade it because I didn't name it. Okay, if you were writing this code yourself and it didn't specifically tell you, you could have just used distance.
Did it just tell you your last submission, or can you find your first 35 submission?
I don't know, I've never,
I've got one wrong.
oh, I left off a, yeah.
I think I got something very close to that at one point.
So, I don't, the solution, see, mine says instructors only for the solution, but I don't know, somebody that's tried it multiple times, does it give you a history of what your submissions were? Or is it just last?
See where.
Probably just the last one, because it would be a lot of memory to try to keep up with. So does that shows y'all, is a good example of mixing in those math functions.
Can you pull it up just a little bit more so I can see the.
Yeah. Absolutely.
Mine does that. I
So,
was trying to read it.
so deciphering the questions part of it is a little harder. So obviously it told you what it wanted the variable to be. You know why it's telling you exactly what it wants the variable to be? Because the grading process needs it to be that, or their auto grader doesn't get it. Because there's some limitation with auto graders. If you don't use exactly the right variables, it doesn't see it. It's correct. Kind of like when you take those online tests and your spelling has to be correct. Your punctuation, you know. I do really bad on things where spelling has to be 100% correct. Y'all have read my syllabi, right? So you know I can't spell.
You say stuff like that, and you use the word syllabi, which means that.
I can use the vocabulary, doesn't mean I can spell it. All right, so the question so far. We all good? Hopefully.
Did that come out correctly?
It did. It did.
I think all of the parentheses have got me screwed up. I think that's
So
where I messed up.
here's the thing. The parentheses will absolutely screw you up. So if you notice that if I got the cursor right here, there's a small outline around them to the matching one.
Right.
So if I put it here, it shows you where the matching one is. And let me make that a bit bigger where we can all see what I'm talking about. Make it super big. But you see how it's drawn a little box around the one that matches it?
Yeah.
So as long as the cursor is right next to it, it's going to show you the matching one. So if I left this one off and I put it here, it gives me a little red underscore because there's not a matching one. And that's what the mistake was the first time I ran it. I forgot to put the closing parenthesis for that one because I got in a hurry and wasn't paying attention. But if you do one of these and the error comes up and it says something about print, that means that you didn't finish the line above it. So that's usually a missing parentheses. And you're like, how do you know that?
Have you done?
Lots of years of making mistakes. All right, random numbers. This is really big now. Let's take it back down a little bit. Random numbers, you will need random numbers from time to time. There is a random number module where you can import random and it will let you create random numbers. I'm gonna tell you that random numbers in computer science aren't truly random. They're as random as we can get with a computer because it's based on a calculation which starts off with clock cycles and that's measured in nanoseconds. And if you knew precisely what nanosecond you submitted that command, technically you probably could do the math and figure out what the number you're going to get back is. But what's the likelihood of you knowing the exact nanosecond that you submitted that command and you want to do that calculation? So it's kind of random. Does that make sense? There's a random method. It lets you create random items or random numbers. You can actually give it a range that you want the random number to be in. So if you want to randomly select between 1 and 10, you can give it that range. The thing you need to be aware of is the first number is included in the range. The last number is not included in the range. So if you wanted 1 to 10, you'd have to give it the range 1 to 11. Don't ask me why. Boggles my mind that they do that. Well, my thought on that is if you're going to make one of them inclusive and one of them exclusive, why not just make them both inclusive or both exclusive? That's my logic on it. But just remember, when you're doing random numbers, the first one is included, the last one is not included. So it goes from 1 to the number just before you put in. That messes people up when they start doing coding. But I may still do it, but last semester I did a guessing game where you had to guess a random number. So the program had to create one, and a lot of people, it was supposed to be between 1 and 100, but if you put in 100, you only got to 99. So it's a common error to forget that it's exclusive of the last number. You can use the functions that come with the random. So you can do random range. You've got min and max numbers you can put in. You can do it in integers if you want an integer. If you know you don't want to partial numbers, you can do random int. Both of these pretty much do the same thing, but they both exist. I don't know. Go figure. You can give it a seed value, or you get a seed value. The first one it gives you back, the first random you get is the seed, and the rest of them are based off of that as you get. This is mostly just vocabulary. Just be aware. We do represent all text in a computer as binary numbers. So there's encoding for them all. This is Unicode. So every character on your keyboard has a number value associated with it. Most charts you see will have the decimal number and the binary number with it. This one just has the decimal numbers. So when I tell you that a capital A and a lowercase a to the computer are completely different things, that's because they have completely different encoding values. And the computer recognizes them by that encoded value, the series of ones and zeros. The project we're going to do has you do an ASCII part, because most of the encoding we do here in the United States is ASCII. There are some languages that do Unicode. One's, I think Unicode's bigger, has more options for more characters, because other languages have more characters than we do. But if you see ASCII, that's ASCII, that's an encoding type. Or you see Unicode, both of basically ways the computer represents characters in the computer as ones and zeros. There are some special characters. New line character is actually a combo character. It's what you see through the return. I think it's /n. Yeah. Backslash or forward slashes should be /n, sorry. Backslashes are often used to help with those escape sequences. So if you see backslash and another value right up against each other, it's generally a special character. This is something useful to know. So when you start drawing your ASCII art, you don't put and you are using using the slashes to make sure you don't put two of them together in a sequence that would be a special character. If you need quotes to show up in a particular string, you might have to use the / and the quote symbol next to each other, things like that. These are things that we're going to use for formatting strings and formatting output. We're going to do a little bit of it in this class. We won't do a whole lot, but we will be doing some of it. The new line one is definitely important. The tab one is something you'll see. If you're using a raw string, the escape sequences can be ignored. A raw string, we don't really use them. This is stuff that we're making you aware of it, but we're not actually going to use it because it existed, it's out there, but for our intents and purposes, you probably won't use it. So it's there, be aware. If you really want to know what the encoding of the integer value is, you want the value of a letter or something, you can use the ORD function. I can honestly say I have never used it. If you want to get a single character, you use CHR. Again, never used it. Sorry. These are, some of this stuff is a little antiquated. And as we move forward, we don't use it as much. So have you guys tried the number games? Anybody? It's the additional practice at the end. It's the last thing before you get to the labs.
Oh.
All right, so we are rapidly approaching 4:30. I am done. That's pretty much all the content for this. So I want to tell you a few things before we leave, just to get you up to speed. Next week is project 1. We're going to do the first project. The first part of that is I'm going to show you how to set up and use idle and save it as a file and not just play in the scripting window where you can see one line at a time. So Tuesday of next week, I'm going to come in, I'm going to open idle. I'm going to have you all open idle, and we're going to set your project up. I probably will do all of part 1 of your project in class on Tuesday with you. We will sit up here with the board and we will walk through the whole thing because I want you to be successful on project 1. Because if you're not, you won't, you know, we need to fix that because I want you to be successful for the entire semester. But I'm going to, and I don't want you to get used to this. Project 1 is very, very simple. It is intended to be simple. It is intended for you to all be able to finish it in class with me over the course of next week. But by no means should you get used to that being the standard moving forward. They will progressively get harder and more in depth. I just want to put that out there for you. Because I've had one person, because I opened it up already, and it's out there, you can go read it. I've already had one person turn it in. Now, I haven't looked at it yet. That's one of my online students. I did not expect that. I put it out there expecting people to go, oh, when are we going to do that? I don't know how to start that. But they've done it, they've turned it in. I'm going to go look at it tonight and see if it's actually right. But I do not have a problem with you guys doing stuff in advance. I do, however, need to make you aware that if I'm not at a point where I can answer those questions, I may say you need to wait till I cover in class. If I have time, I'll try to go ahead and stay at your pace with you. But sometimes I'm not going to have time to jump weeks ahead. So tomorrow in lab, I am going to actually be here to answer any question for any of the lab assignment that is due on Sunday. What, have 3 labs this chapter? 2 labs?
I think 2.
Maybe 2. Yeah, so you have 2 labs. I'm going to help you with any questions. I'm not writing them for you, but I'm going to answer questions on those. And I will answer any questions on the participation stuff that you haven't finished. There will not be a recording for tomorrow because I don't plan on covering any new content. All I'm doing is answering questions. Online students will be allowed, will be given a Google Hangouts link. They can join us if they feel the need, or they can email me. Questions for me? Questions for the greater good of your classmates? All right. Well, I'm going to let you guys know. If you need me, please email me. I know I'm not taking attendance, but I strongly encourage you to be at every class session you possibly can. If you cannot be at a class session, please remember the YouTube link is in at least a couple of places in CourseDen. Go back and look at the videos. And email me. All right. Have a great day, and I will see you tomorrow in lab.